Okay, so now we can draw the FBD again completely because we have already all the information. So the body, okay, the action force here, okay, force here, okay, and then the reaction here at point A. So reaction here, we have moment A, MA, we have force AX and AY. So that include all the forces, okay, action forces, okay, 1, 2, 3, 4, the action force, reaction force 1, 2, and reaction moment MA. So if you are looking at this particular point, okay, all the unknown that we have provide here, okay, is similar to what the fixed support provide. Okay, so actually this case or this ball at A will act similar to what the fixed support. Okay, the fixed support will produce force in X, force in Y, and moment at the point. Okay, so by doing this, we know that when there is a ball, a joint of ball in the problem, so the ball will be act, okay, as a fixed support. So the one of the example of fixed support is ball. Okay, body ball on, okay, ball on to a place by that. Now we know that the ball at point A will react, okay, in three unknowns. Okay, the ball at point A will produce reaction moment MA, force in X direction AX, and also force in Y direction AY. So the ball actually is example of the fixed support. Okay, you have learned before the fixed support will exerting the three unknown, okay, forces X and Y and moment. Okay, so next step we can continue to solve it, okay, by applying the equation of equilibrium. Okay, so we're going to consider all the three equation. Okay, the summation fx equal to 0, summation fy equal to 0, and summation moment equal to 0. Okay, so let's start with summation fx equal to 0. Okay, summation fx equal to 0 with sign positive will follow this direction. Okay, the right direction will be indicated as positive. So we're collecting all the force in X direction. We have AX, okay, AX, okay, and then we have this force 52 5/3, and then we have this force 30 cos 60. So there are three forces here will act in X direction. So we collect all them and put in this equation of equilibrium. Okay, so firstly AX positive, okay, because it's had the same direction here, and then we have 52 minus 52 5/3, sorry, 5/13. Okay, it's 13, 5/13. Okay, negative, okay, because here it is against this direction, so negative. And then the third one, 30 cos 60, positive 30 cos 60. Okay, positive because the direction to the right, same with what we assume here. So all the force in x direction for equilibrium must equal to 0. So by calculating all this value, we can get the value of AX. Okay, we continue with summation of Fy equal to 0. Okay, now we will collect all the force in y direction. Okay, taking down from the FBD here. So we have AY here, AY positive, and then we have force 52 12/13 here, negative 52 12/13. Okay, this force is directed downward, so it becomes negative here. And the last force is 30 sin 60, also downward, so will be negative here. So according to equilibrium condition, the summation of all force in y direction shall equal to 0. So by doing your math, you will get directly the value of AY here. So AY equal to 74 Newton. Okay, the last one is for the moment. Okay, we have got the answer for force reaction AX and AY. So the last one is this reaction of moment at point A. So going to continue here. So the third equation of equilibrium that going to be used is summation moment. Okay, so which point? Okay, we're going to summing the moment here, of course, at point A. Okay, so summation moment at point A in equilibrium shall equal to 0. And we can give the reference. Okay, we should give the reference here. So I want to to use the clockwise as a positive value for moment. Okay, now we will collect all the moment that can be produced in this rigid body. Okay, right. We have many forces here. 1, 2, 3, 4, 5, 6. There are 6 forces in this FPD. Okay, but not all the forces will give the value for moment. Okay, to simplify this, okay, to simplify this moment equation, okay, we can analyze which moment that will produce 0 moment. Okay, there are forces that will produce 0 moment here. Okay, right. Since that this body has no thickness, then for the force that act in for the force that act in x direction, okay, force in x direction shall have no perpendicular distance. Okay, no perpendicular distance. Okay, because force in x should have perpendicular distance in y. Okay, in y direction. For example, if you have some moment equal to F d, so if the force here is directed in x direction, for example, force in x direction here, okay, let's say this is the point of rotation, the point O. So the perpendicular distance should be in y direction. Okay, perpendicular distance here should exist in y direction, because force is in x direction. Okay, so now we can simplify the equation here, okay, by identifying which force lie in x direction. So we have this force 30 cos 60 x direction, so it will have 0 moment. This force also 52 5/13 also in x direction, so will produce 0 moment, and also ax. Okay, so the only force left is ay 52 12/13 and 30 sine 60. So there are three forces left here. Okay, all right, these three forces, okay, from these three forces that act in y direction, okay, ay also produce 0 moment. Okay, although ay act in y direction, but it will go in the direction where the line of action for ay will be exactly at the line of point A that we're going to summing the moment. Okay, so here ay and will go into the point of rotation, point A here. Okay, so ay also will produce 0 moment. So it left with two forces only, right? These two forces will provide moment at point A. Okay, point A. So now we can simplify the equation. So we're going to see how these two forces are producing moment at point A. Okay, this is quite a revision version. Okay, so ulang kaji, revision. Okay, how we can get the moment. So this is point A, this is the force 52 12/13. Okay, we simplify this. So 13 4, this is actually 48 Newton. Okay, 48 Newton, and then here we have force 30 sine 60. Okay, alright, and then we put in the distance. We must clarify the distance. Okay, so the distance here, what distance here? Wait, this is 0.3 meter. This is 0.4 meter. Okay. Okay, done. So continue. Okay, with the summation of moment at A. So firstly we have 48. Okay, 48 Newton force times 0.3. Okay, 0.3. So force perpendicular distance, point of rotation. Okay, here is 48 Newton, here is 0.3. Okay. Okay, how about the rotation? So rotation here is clockwise. So clockwise, the reference here also clockwise. So we will indicate it as positive. So 48 times 0.3, the first component of moment, okay, in this equation. Okay, next is 30 sine 60. So the force 30 sine 60 must be multiplied with 0.4 plus 0.3. Okay, so the length of the perpendicular distance for 30 sin 60 to point A is 0.3 plus 0.4 is 0.7. Okay, similar to what happened here. So this is the force of 30 sin 60, and this is the perpendicular distance. Okay, that is 0.3 plus 0.4, and this is point of rotation or point of moment. And it also will rotate in clockwise direction. Okay, clockwise direction. So it also will become positive. Okay, one more thing. Okay, that is all for the force. Okay, but notice that in the FBD, okay, other than force, there is also one more unknown here. Okay, this unknown cannot be neglected. You cannot neglect this unknown. MA is actually on the point A. Okay, the MA that we analyzed before, this is the unknown. Okay, this is the unknown for the fixed support for ball. Okay, so what we're going to do with this MA? Okay, now we are setting up the summation of moment. So any moment, any quantity of moment that we have in this rigid body must be put in the equation of moment. So now we have this moment A, so the quantity of moment is there, so we have to take it. Okay, just put it in this equation. Okay, just put it, because the unit, the quantity of moment is the same. Okay, this is not a force, this is already in the Newton meter, so you just put in the equation of MA. Okay, all we need to do is to check the sign, the positive or is it negative. So since that our reference is clockwise positive, and here the unknown MA we indicate counterclockwise, so when we substitute, when we put MA in this equation, we must consider it as a negative. So here it will become negative MA. Okay, then our equation is complete. Okay, moment produced by 48 Newton, moment produced by 30 sin 60 Newton, and moment, okay, from the unknown at point A. So all this moment, the summation of all this moment shall equal to 0 in equilibrium. So by doing your maths, okay, you can get this value and this value, and then being left with this unknown, so we can get this unknown. So this unknown is actually equals to 32.6 Newton meter. Okay, and you will get the positive answer. So the positive answer means that your assumption, the assumption of the direction of this MA is correct on your FBD. Okay, so this direction of moment A provided by the fixed support will react in the counterclockwise direction with a value of 32.6 Newton meter. Okay, that's all.